Get the recording started. Well, it is 1 o'clock. I'll continue to let people pop in as we begin, but since we are only have an hour and a half this time, we're kind of talking about two big topics. I probably should get started. So, we can get the most out of today. So welcome everybody. Today we're doing interactive andragogical approaches to geometry and statistics for practitioners. And of course, you know who I am by now, Brooke Istas. And let's see here, let me get my slide thing going here. There we go. All right, so we're going to review just a tad bit about what we talked about last time, about andragogy and about lifelong learning. And then we're gonna jump right in there, and start doing some tasks. I'm going to talk about this idea of what a test talk is. And then we're going to focus on the mean idea. And then we have some final thoughts and just a reminder for next time. But before we begin, has anybody tried or done anything new and exciting or applied anything, any of the math anxiety stuff or any of the lessons that you've used that we've done in your classes, or you would be willing to share? Everybody's quiet.
Well, I think I've shared that we're increasing I like to put it that way, we're increasing my math skills since when I was hired. There was this idea that I was only going to do one thing, and it turned out, wait, we don't do that in adult ed. You're going to also teach math. So I certainly, whatever I'm approaching seems pretty scary to me. So I have used a lot of the techniques you've talked about with math anxiety to help myself, use or work through it. And I do have one lady who does come in that I am working with in math, and she's very low level. She's a level 1, her NRS level, and she feels that too. And we do a lot. And I don't know if this is all part of some of the stuff that you teach, but we do a lot of repetition, and myself and this student, we're okay with that. We need it. And we give ourselves permission to need that. Mm-hmm. And we give ourselves permission to be where we are.
Yes.
Instead of where we want to be.
Good. Yeah, that's such an important piece that you mentioned, Darcia, just about being okay with where you are and your thinking. So much of what we know about how adults learn and about math anxiety is that the traditional method of procedure-based methods cause some of that trauma in people's lives. And so being okay with exploring and trying new things and reflecting on it is a higher level of metacognition that we really want our students to get to. Actually, it would be great if all students would get to that place, because it's through that reflection and why does something work that people, have a deeper mindset, and then it reduces that way people see that math can be fun. It can really be fun and not this scary thing. So one of the questions, oh, Karen, did you want to add something? Oh, okay, that's fine. That's fine. One of the questions that I always get is, will this be on the test? Well, one of the things that as practitioners that, we need to remind ourselves of is, of course, the college and career readiness standards and the big key shifts of the focus, coherence, and rigor, focusing on just certain standards, and instead of just going a mile wide through that standard and just a little bit deep, we need to really kind of push ourselves a little bit deeper than what we normally, it's not surface. We want to go deep, and then building on a student's understanding and then extend it to new ideas and new thoughts about how something works. I think we illustrated that a lot last time with algebraic thinking, just looking at what do we know, and then how can I extend that? And then, of course, rigor, rigor is, teaching everything for conceptual and procedural and application, but it gets to be like to the point that how do we do all this? Because we have to cover everything an adult learner needs for this critical test that covers everything from kindergarten to grade 12. And we have them for a short time, and their attendance isn't always consistent. So, but we know that research shows, a researcher, Dr. Bowler, if you're not familiar with her, she did a longitudinal study with students using what they called open-ended projects. And the tests were not taken and work was not graded, but they focused on the metacognition and the higher learning of the application of these open projects and the questions about processes and procedures. They did review those, but they were normally just within the last few weeks before some kind of a standardized test. And what they found is that those students scored significantly higher than compared to the group that worked on similar questions to the exam and then took frequent tests. So I say all that because sometimes, as teachers, we think, oh, this is on the test. I need to really focus on this. They need to unpack that. But knowing that these open-ended projects that we've been looking at, these questions, these different activities actually will get you there. It's the reflection on the process. It's having that student reflect on what they're doing and then being aware of other additional strategies and why does it work? One of the most powerful questions that an instructor can ask is why? Why does this work? What is the result? A lot of times students will read through something and they'll say, I don't know. And then you say, well, what is the question asking? And then they have to go back and read it because they didn't read it for that mindset. They just read it to just do something. And so it's this idea of moving past this idea of things being a process or a procedure and trying to look at it as more creatively and flexibly as what we want math to be. So what does this mean? So for us, the teaching that is comprised of those three shifts, the focus, the rigor, the coherence, and it involves problem solving, flexible thinking, building on prior knowledge. This all will prepare our students for math exams as well as real life math, because at the end of the day, that's really what we want our students to do is real life math. And so when we think about creating math tasks, we want to create those that allow students to use their experience or pass understanding through scaffolding. It's amazing what a student is able to solve without being formally taught how to do something because they've had to overcome a lot of these types of problems that appear in their everyday life. So focusing on that connection and building upon it is very helpful. So, and of course, allowing space to show multiple ways and to reflect on that, because when students are shown a different way or a different perspective, and then they decide which way that they like to do that activity, then they're more likely to increase their understanding of what's going on. Oh, back up. So how do we ignore the high stake tests? The test is really the driving factor for all our learners. So as and we have them for such a short amount of time that we really want to give the students what they need. But what we have found is that you don't need to abandon those three shifts. And that you can use standardized problems to help deepen conceptual understanding. And we're going to talk about that today. And that it's important to tell them that it's not about remembering and reproducing the correct approach. It's about creating a sense of meaning for themselves, that it's about that finding an approach that works best for them to build confidence on that flexibility of thinking. And then, of course, self-efficacy is so important to attempt questions. And self-efficacy, just because I know it's the big buzzword, sometimes we forget what it means, but it refers to an individual's belief in his or her capacity to execute behaviors necessary to produce specific performance attainment. It's just like metacognition. I've been reading a lot lately about metacognition, and I know that word and I've heard it a lot, but really it's about reflecting on the learning that you personally learn. And so giving students that space to reflect on that is very vital in their understanding and development. So, a couple questions for you guys. If I wanted to know whose shoe would leave a larger footprint, how could I find that out? Would it be area, perimeter, length, width? What do you think?
I would say area.
Okay. What do others think?
If I weren't given those choices, I would say length.
Length, okay.
How you're defining larger.
That's good. Yes. So Ruth brings up a very good thought there. If I wanted to know whose shoe would leave a larger, well, what do I mean by larger? Do I mean larger in area? Do I mean larger in length? Maybe I mean larger in width. Maybe I mean larger in the aroundness of it. Can you think of some situations where you've had to compare or estimate size, like in your life? Sometimes for me, it's going from summer to winter clothes. You know, just estimating that size. Is this going to fit this year type of a thing? But does anybody else, can they think of something?
Ordering pizza, which I
Oh.
know is a common math example, but I swear when it comes up, I can never figure it out. When you're figuring out which size of pizza to get for how many people, what's the better deal?
Yeah. I mean, we do this a lot. We went to go look for a microwave oven and trying to decide how big of one's going to fit in the space on my kitchen cabinet, you know, just to compare the difference, you know, estimate the space that I have. And then is this going to be too big, too small? How much cabinet space? You know, anything that can go into something else, you know, car going in a garage or just thinking about how much, like which container can I put my leftovers in, you know? Because sometimes you think you get a container and it's too small, and then you have to get another one because it wasn't big enough to put all your stuff in. It's like your pizza problem, Nakia. I mean, you think you know that estimation and trying to figure that out, but sometimes it can be a little bit difficult. So all of these things, you know, when you picture those situations, you're thinking about the area, the perimeter, the width, the measurement of something. Okay. So I say all this because I'm going to put you guys into groups and I'm going to give you your first activity, and you will work, you know, 10 to 15 minutes to get through as much as you can. And then we're going to come back together. Okay. So let's see, there's 2, 4, 6, 8, 10 of us. So I think I will put us in groups of 5 groups of 2, 2, 4. Let me make sure I get my math right. 4, 6, 8, 10. Yes, 10 of us. Okay. I'm going to create those groups. And then before you just head over there, I'm going to put the different links in there so that way you can get to your particular group. And then I will open everything up. So, copy. Okay, there's the different groups. And then now let me open up the rooms. And now you can head off to your different areas. Welcome back. We'll wait a few more minutes for everyone else to get back in. Find out what everyone. All right, welcome back, everybody. Did you get through most of the activity? I think that was
Most of it, yeah.
okay. I was listening to some conversations about the last question about so we'll talk about that. So let's look at what was the order for area? Group 1, did you come to a consensus together?
We did, we
Okay.
think.
Okay. Okay. What was your order?
Well, our order was, actually the conversation was, boy, I think I remember doing this in the Empower.
Yes.
I wish I could remember it. We went smallest to largest was 2, 1, 6, 5, 3, and 4.
1, 2, or excuse me, 2, 1, 6, 5, 3, 4. Is that what you said?
Yes.
Okay. And room 2, what was your for area?
I think we had the same, except we had 5 and 6 switched around, but I think that we kind of kept flipping them back and forth and changing our minds, so.
Okay.
Yeah, it's hard to gauge though. Like you could kind of, flip flop them, but yeah.
Yeah, too bad you couldn't cut them out on the screen, right? That's
Yeah.
okay. Room 3.
We had the same as group 2, 2, 1, 5, 6, 3, 4.
Okay, thank
But
you.
we too had a discussion about numbers 5 and 6.
Okay. All right. Let's see. Group 4.
Yeah, we also had 2, 1, 5, 6, 3, 4.
Okay. Getting some good answers. Okay. Room 5.
We had the same. Oops.
Okay. So my teacher book says 2 and then 1, 5, and 6 are equal and 3 and 4 are equal. Does that seem right to you guys?
I knew that those last 4 were equal. I knew it.
Yeah, I had down that 3 tied for 2, and then I was highly suspicious of 3 and 4, but I thought maybe it's an optical illusion. So yeah, I had 1, 5, and 6 tying for second spot when it came to area.
Yes.
To me, 3 and 4, even if you tell me they're the same, 4 looks so much bigger than 3.
It's that optical illusion.
Mhm.
Here in the Midwest, I always say that 3 is like when the wind isn't blowing, and 4 is when the wind is blowing and pushing the barn over, because we have a lot of rickety looking barns around here. So it seems to help students kind of remember parallelograms and rectangles. So just a little note is that so number 2, the area is half of 1, 6, and 5, and 1, 6, and 1, 6, and 5 is half the area of 5 and 4, or 3 and 4. So that's kind of an interesting. So what kind of method did you use, and how did you because we're eyeballing it. So what did you like? How did you get to these your answers?
I think, I know, oops, I'm sorry, Jeremy. I think that can speak for Becky, but we pretty much, it was all just based on looking at it,
Mhm.
and it was just purely visual.
Mm-hmm. Okay.
And it was frustrating that we couldn't manipulate the shapes to kind of move them around and see.
That's what I was saying too.
Yeah, I didn't know if anybody did anybody use their pen or anything and maybe say, okay, this side is about half my pen and
Yeah.
or my finger
I was doing this.
okay. I mean, because yeah, it is hard in a virtual space. You know, I mean, unless you just have a ruler laying around, I don't even have I'm looking around my office. I don't even have a ruler laying around to be able to put up on the screen. Yeah, so it's amazing how good our visual is for area being able to determine. What about perimeter? What was the order for perimeter? Group 1.
We pretty much kept it the same.
Okay, so 2, 1, 6, 5, 3, 4. Okay, group 2.
This one I decided to flip flop with Nikita because I was like, I can't make up my mind with between 5 and 6. So
Okay,
flipped.
okay. Okay, so 2, 1, 6, 5, 3, 4. Is that the one you decided on, Luke?
Yes.
Okay.
Yes.
Group 3.
We kind of had the same order and little bit of a flip flop between 5 and 6 again. But this one was trickier because you couldn't just superimpose images on each other because then you would be adding extra lines,
Yeah.
that wouldn't be a part of the perimeter. So
Yeah, that's good. I like that. What about group 4? Or I
We
guess
actually-
it's go ahead. I'm sorry.
We actually flip-flopped a couple of them. We went 1, 2, 6, 5, 3, 4.
1, 2, 6, 5, 3, 4. Okay. Okay. I like that. That's interesting. And then group 5.
I was no longer convinced of the three-way tie between 1, 6, and 5. I
Mhm.
think, but there's still 2 the smallest, and then I think 6, then 5, then 1, and 4 is definitely bigger than 3 this time.
Mhm.
Their perimeters.
Mhm.
Yeah, that was my thought.
Okay. So my teacher book says this. So 2, 1, 6, 5, 3, 4. So even visually, you guys, most of you were able to kind of articulate that out. What about that question that was in there about the if you compared 2 shapes by area and knew which one was bigger, would their perimeters also be bigger? What do you think about that?
We had a question about, are we comparing apples to apples?
Well,
Yeah.
if you knew that the shape was had the biggest area, so the 2 shapes by area, and knew which one was bigger. So I think you could just pick any 2 shapes. And you knew the area would be bigger, like of whichever shape it was. Would the perimeter always be bigger?
And I'm going to jump in and speak for Darcy this time. I think we both agreed that we had this gut feeling that area and perimeter are not specifically proportional or linked, but neither one of us could prove it. So
Yeah, I mean, so if you think about the order here that we showed 1, 5, and 6 to all be equal in area, but look, their perimeters are all different. Just by, I mean, from what my teacher book says, going off of course, believing that it's true. Here you can show that, equal, like you can definitely show that equal area doesn't necessarily equate to equal perimeter. And like we all said that 3 and 4 were equal as well. And once again, so, if it's interesting to think about. I think that when I think about this, I think about So in calculus, I know that we don't teach that in this, we do these things called optimization problems where we try to optimize the space based off of the area to figure the perimeter to build a fence or something. And so they are not linked, like you said, Becky. So, but it is a kind of a mind puzzle, if you will. It kind of is a weird thing for our mind to wrap around. So what do you notice looking at these two orders, both by perimeter and area? Is there anything that just jumps right out at you that?
Well, speaking for myself, what jumps out to me is that eyeballing it is not a very reliable way to determine either area or perimeter. I feel like even though we got the right answer, um, there were definitely some uncertainties, and I think as you said, the idea that the area and the perimeter aren't necessarily correlated is really kind of mind-boggling when you try to wrap your mind around that.
Yeah, it is. I guess it's because maybe it's something we don't think about a lot, but believe it, they do in marketing. I know that they think about representation all the time in marketing about things. Anything else that jumps out?
Just when students are learning their multiplication tables and you have like 12 blocks and you can arrange them in a variety of ways, your area is going to stay the same. So a 2x6 or a 3x4 or 1x12, they're all areas of 12. But those three shapes have distinct perimeters. The 1x12, that's a 13 and 13, so that's 26. The 2x6, well, that's an 8 and an 8, that's 16. And the 3x4, that's a 7 and a 7, that's 14. So with having three areas the same, we've got three different perimeters. And, if you take the biggest perimeter, the 1x12, with a perimeter of 26, and you just grab something that's going to have a bigger area, say you want an area of 15, but you got to shrink it down, arrange it so it's going to have less than a 26 perimeter. A 3x5 does that nicely. A 3x5's area is 15, and the perimeter is just an 8 and an 8, a 16. So there you've got your counter example.
Yes, thank you for that. And Jennifer also had made a comment like that in the chat about area and its perimeter.
That's Ruth's example. I just cut
Ruth.
it and put it in there.
Oh,
Okay.
thanks, Jennifer.
Okay. So we talked about the ways that we compare the shapes. And so how does looking at the perimeter differ from looking at the area? It's not a trick. I know you guys know this. When you're looking at the shapes, how did you look to determine perimeter compared to looking at area?
Well, I mean, it sounds really simplistic, but it's the difference between like outside and inside.
Correct. Correct. It is. Yes, very much. The outside and the inside. So which do you expect to use more frequently? Like in your everyday kind of like dimensions, perimeter, area, angle measurements? Which one do you think you used more often?
Okay, I have a real world example, Brooke. I know you
Okay.
love these.
I do.
We just moved into a new house. I've been using all of them constantly, right? I mean, like we're taking pictures that hung on one wall for 24 years and like laying them on the floor and trying to figure out how they would go together on a new wall. We're measuring things to see which piece of furniture is going to fit where. And I actually became obsessed with the Zillow pictures of the interior of my new house before we took possession, like looking at things like, okay, so if the windows are this wide, this dresser should fit right there. And like in my head, I had arranged a lot of furniture, kind of doing the same thing that we just did.
Yeah.
So I think, it's a kind of a crazy example, but I think people can kind of understand that. Like, you move into a house or an apartment, you've got to see how things fit. And it really is, perimeter area, angle measurements, all those things come into play.
Yeah.
And my
I-
spatial relations are not great. So,
Mine either. I just bought a bigger car. So for me, I always am thinking of how much space is my car going to take up when I park next to somebody. So yeah. Yeah. So, well, we're going to jump back into our groups. I have two activities here. So I'm going to give you about 15 minutes to kind of work through these together. I'll go ahead and post those in the chat, the different links, and then I will open up the rooms and then you guys can have at it and I'll pop in and out. Welcome back, everybody. Welcome back. I know I didn't give you enough time to kind of get your cakes cut, but old Mike and what was Mike and Rachel? They both were excited about cutting their cakes all wonky, weren't they? So just a little bit about this. This is activity 5 from the Over, Around, and Within, the curriculum from the Empower series, if you have it, which you should, in your programs. This is just a little sample of it because it's a much bigger lesson. And since we also need to talk about other things, we couldn't just delve in and stay with geometry, but hopefully you can see how to, incorporate that deeper cognition, that thinking that we want students to do. So let's talk about this idea of talking about the test. So the purpose, of course, whenever we want to talk about an exam or some type of test question for our learners, is to support them in extenuating their learning within the context of a test question. And we're trying to create those learners to be flexible and creative. And of course, we want to support their self-efficacy and their willingness to attempt them. The purpose is not to teach students how to complete test questions or complete different test types. I should say types there. I have a little bit of a typo. So one of the processes that we talk about when you decide to do a test talk is how do you select a question? When it really doesn't matter what test question that you choose, and it really doesn't matter where you introduce it, because a test talk can really be at any point of your lecture, at any sequence, because it helps sometimes when you choose a question that is not connected to the work that your class is currently doing, you give your students good practice to make sense of questions without having any context, which a lot of adults can solve questions more than what we can assess. And so sometimes it's just nice to have them out there. I think it's good to share the expectations. Say, I'm going to give you a question like you might see on a high stakes test. It may look unfamiliar or intimidating, but that you just want them to try and to look through it. And I want them to choose an answer they think is correct and to explain why they chose that. You can assign questions to different students and share their answer choices with other students. There is a whole resource that I'm going to share with you guys that comes from Asabase. You can see the copyright at the bottom there, talking about how to facilitate strategies for sharing. And we're going to walk through some of these and to ensure that each student has a strategy that they like and encourage them to do note taking. And it's always good to do that reflection piece. So here is a test question that they're likely to see on some high stakes test. So what percentage of the area of a park below is taken up in square ground? Now, some of our students will just dive right in and start doing an algorithm. Others of our students may find different ways. So I'm going to walk you through some different ways. So on a student page, it would look something like this, where they have their strategy, and then we're going to share other strategies, and then they're going to talk about why they like that strategy. So here's a strategy to sketch a new diagram for a better estimate. So they just move the playground over to where they can estimate, so that they know that more than half of that is the width, and it's less than half for the length. So it's a good way for students to kind of estimate their answer. Another one is to use, these are called Singapore strips, to where they think about, okay, whole and part reasoning. So if I know that the whole area is 12,000 and then half, and then they just continue to benchmark it down. So using area with estimates with benchmarks is also good. Oops, skipped one. And reason with using equivalent fractions. Some students may choose to do this as well, where they, and there's a lot of ways to get to 100% in this thinking. These are just some ways that students, you can encourage to show multiple ways to solve problems, which is a higher level of cognition, and allow them to think about as many ways as they could to solve that problem. And then share out. Test talks, you know, have to deal with all of these things, but really they are student-centered teaching, meaning that the student leads the discussion through looking through the process and thinking about different things. Sometimes they will hear a discussion that another student made and be able to build off of that. It is very self-directed, which is a big part of, you know, of andragogy. We're creating problem solvers, and then we have that reflective piece that we want our students. Here's another. Let's look at statistics. Here's another test question that they may see on a high stakes test where Dorothy has scored 83, 92, 85, and 94 on her first 4 tests this semester. What does she have to score on the 5th test to have an average mean score of 90? So a couple things that they need to be able to understand. That what does mean? So vocab is important, and then multiple strategies to understand mean, because we all need a lot of tools in our toolbox. So once again, the student page has the question, my strategy, my favorite strategy, and I like this strategy. So estimation is a good one. We know that mean means the middle. So they observe, maybe a student observes that 2 of the test scores are above 90. 2 of them are below 90. The 2 that are below are further below from 90 than the ones above. And the current average is less than 90 based off of that. Oh, I went past it. So she already knows based off these estimations and reasoning that she'll need to score a score that is greater than 90. Another way to do this is to use our favorite number line, where then they draw that where the target mean is, and then they draw like 2 above the target, 4 above, 5 below, looking at the test scores. Or you can diagram it. So instead of having a number line, maybe you're diagramming it so you can try to reason it out. It's just a different way than just using the algorithm. Here's another one. For me, this is the one I always like, just because I use sticky notes, you know, just the square old stickies for these. I mean, I would make them worth 5 or something like that. So that way you wouldn't have 92 stickies. That's a lot of stickies, but you know, use a number system that makes sense. And then the beauty about that is you can move them. So you create equal piles, because that's what it means to find the average. And then once you have that target, notice that the different colors that when you move them. So notice that the 5th stack here, the mystery 5th score, this fills it in, what's left over. And so when you restack it, you can see how much more that stack needs to be. And then here's another way. So you have 5 piles of all the same things. That's the mean score of 90. 1 big pile all together, 450. And then you have your 5 different piles. And so if you think about moving those piles around, you can begin to think about the way that they would be organized. And then this one is not one that we teach a lot, but it is a good one. And it's to use estimation to inform their guess. So you use the information that results in what we call an informed guess. I mean, they have all the different pieces here. So, but looking at it, you know, you wouldn't just choose 88. That wouldn't be a very informed guess. But so teaching our learners to look at the information that is given and how do you make an informed guess and then check your answer. So in the remaining, like we have 10 to 15 minutes. So let's do probably 15 minutes because we're going to be out of time pretty soon. I have another problem to discuss. I want you to consider multiple ways of understanding what mean means, those ones I just showed, and just try to incorporate something different than the algorithm. You know, so many times us math teachers, we know the algorithm so well that we're comfortable with that, but our students, they don't know that algorithm. And so they're not very comfortable, and it's hard for them to remember a process or a procedure. So if we can help them conceptually understand what's going on, it will be rooted better for them, and then they can pick out the strategy that makes sense for them. So I've posted the links for that in your group. Let me open up your groups here. Let me get to my breakouts, and I will open them, and they should be available for you. So Okay, let's go to Jeremy. Break rooms. Close all rooms now. Welcome back. Welcome back. About 30 seconds and everybody else will be back. Hour and a half goes fast, doesn't it?
Very fast. And I have to say, I lost all whatever because comfort had so many had troubles. It's like,
Yeah, yeah. Well, I'm gonna give you guys a resource to kind of look at. And I'll give it to Kim as well to post as soon as everybody gets back.
and she says now she can see the screen, so I
Of
don't know
course.
what's going on.
Of course.
Sorry.
Yay! Okay, I think everybody is back. So I'm going to go ahead and post this resource. I'm going to give it to Kim as well to post on the website. This is a resource from my good friend Sarah Luhalong, or Longbird, Lou Longbird. She does this entire series about will this be on the test? And it's a really good packet of information that talks about these test talks and why they are so important to help our students. Remember, it's not about memorization of problems. It's about helping them incorporate that creative way of thinking. And if you're just dying to know where this mean idea came from, this was lesson 7 from the Many Points Make a Point book. So if you should have that and the teacher book there is one called The Mean Idea. And then the lesson after that is called The Median. So it's really kind of I like this book a lot because data is super important in our adult learner lives, and for them to conceptualize the information that they're getting is going to be so important, especially as time goes on. All right, just in the few minutes that we have left, remember, math learning is not about remembering and reproducing a correct approach. It's really about making sense of tasks and finding an approach that works for your student, that works for them. Let them discover, let them build that confidence. You know, it does create lifelong learners and not just what we call mimickers, where they're just following you around, because guess what? You're not going to be in their pocket for them to follow for the rest of their lives. So it's going to be important that they become familiar with what's going on. Now, also in this resource, Sarah does a really good job to talk about not all items are good test talks. Basically, if items are unfamiliar or the notation is unfamiliar, those are not good test talks. You will be surprised at how much our students know, but also we can't, possibly teach everything because we only have them for a limited amount of time, and they will encounter problems that we just can't teach them, and that's okay. What we want to do is we want to encourage that math is not something that you just do. It's something that you think about. It's this process of thinking, and we really want to get away from this idea of it being process oriented, because there really is multiple ways to approach problems. And so I just want to encourage you, as someone that was classically trained in mathematics for many years and was able to figure math at high levels, I didn't always know why it worked, but I could get you the answer. Now I'm focused more on why does that answer work, and what's the meaning behind it. So I just want to put out a reminder that our last session 5, is on growth mindset. We're going to really speak about this a little bit longer, about helping students develop a mastery to empower them. This is our last session, so you don't want to miss it. It's June 13th and 14th. And we'll have more time together, so we'll unpack a whole bunch more stuff, but it is going to be sad because it's going to be our last time together. Oh, but thank you all for coming today. I appreciate it. I hope you found some useful things that you can take back to your classroom or something to consider. So, and it is 2:30. Yay, I did a good job.
Thank you.